Hey guys, I know it's been a while. I hope you guys didn't think that I forgot about you because I did not. It's just that the second half of June has just been crazy busy, guys. I can't believe how fast time is going. It's July 1st. This assignment here won't be due until I think I put the 10th, and then I felt bad that it was a Friday, so I think I put the 12th. So it's due July 12th, and then assignment 3 and 4 will probably be uploaded pretty quickly. So here we go. Let's get right into it. I'm not going to do proof of any of this, guys. It's already in your notes. So hopefully all this is a review. So here are all the trig identities: double angles, half angles, law of cosines, law of sines. We actually won't be using these today, or at least not right now. Maybe we'll get to it in assignment 3 or 4. At the moment, I have algebra for assignment 3 and assignment 4. It's actually going to be like a dual assignment for you guys and the other class. But let's go right into it, and let's take care of these examples. So yeah. All right, so example 9. Assume that theta is a positive acute angle. Given that sine theta is 12 over 13, find sine 2 theta. So hopefully you remember that sine 2 theta is equal to 2 sine theta cosine theta. And if you didn't remember that, you can just scroll up and you can just find it. Where are you? Right here. So there it is. So since I already have sine theta, I need cosine theta. So 12, 13, so I'm going to draw a reference triangle. Here's my reference triangle. Here's my right angle. There's the theta. Sine is opposite over hypotenuse, so opposite hypotenuse. So I'm missing this side here, and I'm not recognizing that I'm using the word quote-unquote so a lot. Let me see if I can use an alternate word. Anyways, it's a 5. You could have also have done like Pythagorean theorem. Square root of 13 squared minus 12 squared will get you the square root of 25, which is 5. So there it is. And so now let's just plug into our equation. So sine 2 theta is equal to 2 times sine theta. Well, sine theta is 12 over 13. That was given. And then cosine theta is going to be 5 over 13. All right, let's see if we can do this without a calculator. I think we can. 12 times 5 is 60, and then 60 times 2 is 120. 120. And then 13 squared, those are always the easy ones to remember, right? That's 169. And I believe that's it, guys. So yeah, there it is. Now, I don't want you guys to freak out. I don't want you guys to be a robot. It's very easy to become a robot. Make sure you understand what this means. This means that if I were to find the angle that creates 12 over 13 and I were to double that angle, that sine of that angle that was doubled would give you 120 over 69. So for example, I have my little calculator right here. Let's see what 120 over 69 is in press menu, add calculator. 120 over 169. Let's see what that is in decimal. So 0.071006. Oh, that's not one. That's a good way to start. And I'm not gonna, I'm just gonna go one time through this, guys. And if I make mistakes, I make mistakes, and there it is. So 0.710059. So there it is. So if I were to do, let's just find the angle theta. So if I were to do arc sine of theta, so arc sine of 12 over 13. So this is gonna give me my radian. And I don't really care what it is. Well, it's actually going to give me my degree because I have it in degree mode right now. And I'm just going to store this, guys. I don't really care what that number is. I'm just going to store it to A. And I'm going to push enter. So right now I have it stored as A. So if I push sine of 2A, I better get that 0.71. So check it out. Sine, and I'm going to write 2A. And I'm going to push control, enter. And we get that 0.710059. So there it is, guys. That's what it means. I just double that angle, and sine of that is 0.7199 or whatever, 0.7100 or whatever it was. All right. For positive acute angles A and B, it is known that tan A is 45 over 28, and sine B is 4/5. Find the value of cosine A minus B. All right. So cosine A minus B is, let me see if I can remember correctly, cosine A cosine B plus sine A sine B. If you don't remember that, guys, just scroll up and you will find it right there. Cosine A minus B. So let's see. I have tan, and from tan I'm going to get sine and cosine, and I have sine B is 4/5. So let's go ahead and do this again. I guess I don't have to draw my triangle that large. Not to scale. Here's angle A. Tangent is opposite over adjacent. So this is 45. This is 28. And it looks like a special triangle, guys. I'm not 100% sure. I should be 100% sure, but I'm not. It does look like a special. Let's see. 28 squared. Sorry, guys. When my laptop is lagging, because I'm trying to do a lot of things with it. So 28 squared plus 45 squared. And then I push enter, and there it is, 53. So that's 53. And then here is my other one. Sine B is 4/5, so 4, 5, that's a 3. All right, we got all our values that we need, guys. So let's go right into it. So cosine of A minus B is equal to cosine A. So cosine A is 28 over 53. And then it says cosine B. So cosine B is 3/5. And then plus sine A is 45 over 53. And then sine B is 4/5. And then let's see if we can multiply this here. So let's see. 28 times 3. 30, 60, 90, 246. So is that 84? And then 53 times 5. Well, I know 5 times 5, so 250, and then I'm going to add another 3, 6, 9, 12, 15, and then 15, so 265. I could be wrong, guys, so make sure you're checking my work. 45 times 4, that should be pretty easy. 45, 90, 180, and then 265. And then let's see, 180 plus 84, so 18 and 8, so that's going to be 264. Why did it take a while there? All right, so there it is, guys. I think we are correct. You can check my work. You can always find angle A, and you can always find angle B, and then put cosine of A minus B, push enter, and see if you get 264 over 265. I'm pretty sure. I'm 100% sure it's correct, by the way. All right, let's keep going. So now we got radicals. Oh, geez, radicals. So let's see. Given sine A is 3 squared root of 13 over 13. Sine B is square root of 5 over 5. And then angles A and B are both in quadrant 1. Find the exact value of sine A minus B. All right, so let's go ahead and do that. So sine A minus B is equal to, let's see, say it with me. Sine A cosine B minus cosine A sine B. Good job, guys. I'm not trying to annoy you. I promise you I'm not. Please don't give me a thumbs down. I would really prefer a thumbs up there. All right, let's go ahead and continue, guys. Triangle here. I'm going to call this angle A. Sine is opposite of our hypotenuse, so I'm going to go 3 square root of 13. And I'm going to call this guy 13. And then here's my other triangle. And there's my right angle. Sorry that my triangles suck. I apologize. Square root of 5 and then 5. So we got to find the adjacent sides for both, right? So let's go ahead and do that. Square root of 13 squared minus 3 square root of 13 squared. And that's going to give us some number. I do not know what that number is. So we're just going to use the calculator here. So square root 13 squared. I know 13 squared is 169, but let's go ahead and continue. Minus, and then I'm going to put a little parenthesis here. 3 square root 13. That sucks. That sucks. 13. There we go. Close it, put a square on it, and push enter. So 2 square root of 13. So 2 square root of 13. All right, let's do this guy here. This one's easy to do. 5 squared, that's 25, minus the square root of 5 squared, that's 5. So 25 minus 5, that's square root of 20. And well, 20 is 5 times 4, and the square root of 4 is 2. So 2 square root of 5. So 2 square root of 5. All right, I think we're good now. So sine of A minus B is equal to sine A. Well, here's A. Sine A is 2 square root of 13 over 13. And then cosine B, so here's B. Oh, I made a mistake there, huh? Sorry, guys. Erase that 2, put a 3. Good thing I caught it. Sine A. Cosine B. Cosine B is 2 square root of 5 over 5 minus cosine A is, that one is 2 square root of 13 over 13. And then sine B is square root of 5 over 5. Okay, so let's continue. That is that equal sign. Let's see, 3 times 2 is 6. Square root of 13 times 5, well 12 times 5 is 60. 13 times 5 must be 65. And then over 65 minus 2 square root 65 over 65. Square root of 65, square root of 65. Bases are the same, or kind of. That's kind of like a variable and a variable. So 6 minus 2 is 4. 4 square root of 65 over 65. And there it is, guys. And I'm pretty sure, I'm 100% sure that's correct. I didn't see any other mistakes. If you see any, let me know in the comments. Or if I confuse you, let me know. I hope I'm not going too fast, guys. If I am, push the pause button. Okay, let's keep going. It says cosine x is 1/6, and what is the positive value of half x, or cosine half x? So this is a half angle problem. Without looking back at it, I want to say, now I'm wrong all the time, of course, but I want to say that my half angle formula is for the cosine, it's a positive, so cosine x. Now, if you don't remember that, you can just scroll up, and it is right here. So remember the plus minus, it needs to have a plus minus, but in this case, they're already telling me positive value. Where would it be negative? Well, if this cosine x, if this angle was in the fourth quadrant, and I don't know, make up some number like 280 degrees, and you take half of 280, that's 140, and 140 is in quadrant 2, so cosine of half x should be negative because cosine is your x-coordinate, and your x-coordinate is negative in quadrant 2. So hopefully that made sense. Hopefully I didn't talk too fast. If you think I spoke too fast, guys, rewind it and check it out again. All right, so here we go. Cosine of half x is equal to the positive one of, here's my 1/2, and then 1 plus, and then my cosine x was 1/6. 1/6, and don't leave it like that, guys. Let's simplify it. 1/2, and then 1 is the same thing as 6 over 6, so 6 plus 1 is 7, so 7/6. And then when we multiply this guy, you're going to get square root of 7, and then 2 times 6 is 12. And then we can, you know, that's like the laws of exponents here, right? So you can say square root of 7 over square root of 12. Now remember that 12 is the same thing as 3 times 4, and the square root of 4 is 2. So square root of 7 over 2 square root of 3. Let's see, 3 times 4, yeah. So we're still in pretty good shape. And since we don't want to have a radical in the denominator, we're going to go ahead and multiply by square root of 3. So multiply both the top and bottom by square root of 3. 7 times 3 is 21, so I'm going to write square root of 21 over, and then square root of 3 times square root of 3 is just 3, so 2 times 3 is 6. And there it is, guys. Another happy face. Another satisfied customer. Okay, let's keep going. I'm sorry, guys. So example 13. I feel like these are pretty straightforward. I on purpose gave you guys the easy ones, guys. You're not going to have any that are like crazy quadratics where you have two factors and you have to find both. I just put simple ones in here. So example 13, it says 4 cosine squared minus 3 equals 0. So move the 3 to the other side. So you have 4 cosine squared x equals 3. Divide by 4. So now cosine squared x equals 3/4. And then we're going to take the square root to get rid of that square there. So you're going to get cosine x equals plus minus. The square root of 3 stays the square root of 3, but the square root of 4 is 2. And then on the unit circle, where are you plus or minus square root of 3 over 2 for cosine? What happens at all the ones that are over 6 there? So I'm going to say x equals, well, between 0 and 2 pi, right? Pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. And there it is, guys. Straightforward. So here it is, example 14. This one's one of the tougher ones. And I did this on purpose. I put one of the harder ones here so you guys don't say, oh, Travis, you're just doing the easy ones. So recognize the domain. It's between 0 and 10 over 3. So I'm going to go ahead and start solving. First thing I'm going to do is I'm going to move the 1 over. So I'm going to write cotangent of 3 pi over 5x equals 1. And then here's where Delta Math decides to do the inverses of both of them. And it turns it into tangent. I'm okay with, like, you should feel confident in your abilities, guys. So I'm just going to keep going with this right here. I know that cotangent is x divided by y. And the only time that cotangent is 1 is in quadrant 1 and in quadrant 3. So I can just take quadrant 1 and just keep adding pi to it, right? So that's what I'm going to do. So I'm going to take the inverse. So I'm going to write 3 pi over 5x equals arc cotangent of 1 plus pi. Or pi n, sorry. If I add pi n, if I add pi to this guy right here, or this one in green, I am where the blue one is at. All right, so like I said, I already know what our cotangent of 1 is. This one happens at pi over 4. So I'm going to write 3 pi over 5x equals pi over 4 plus pi n. So now what I'm going to do to isolate the x, I'm going to multiply by the reciprocal of whatever I have in the front. So I'm going to multiply by 5 over 3 pi. And whatever you do to one, you do to the other. So 5 over 3 pi. That's a 3. It just came out dumb. All right, there we go. So let's see. 5, the 5's cancel out here. The 3 pi's cancel out. So I'm just going to have x equals, and then the pi's are going to cancel out. So you're going to have 5 over, and then 3 times 4, what's that, 12? Plus, again, the pi's are going to cancel out, and you're going to have a 5/3 n. And then that 5/3 n, guys, is actually the period. So don't be shocked. Like, don't be like, oh my God, where did that 5 over 3 came from? Now, check it out. I want you guys to notice that 5 over 3, if I add 2 of these guys, I'm going to get to 10 over 3, right? 5/3 plus 5/3 is 10 over 3. So 5/12 is definitely a number below 10/3. And if I add 5/3 to it, it's definitely going to give me another solution, another answer. So what are my answers? My answers are for sure 5/12. And then 5/3 is half of 10 over 3. So yes, you can add it to the 5/12. So on the side here, I'm just going to go 5/12 plus 5/3. And then I'm going to do common denominator. So let's see, I'm going to multiply that by 5 over 4. So you have, let's see, 5/12 plus, so 5 times 4 is 20 over 12. That's the whole point of that, right? And then 20 plus 5 is 25. So 25 over 12. And there it is, guys. I hope I didn't do any mistakes. I don't see any. Let's see, 4, 5. No, I think we're good. So these are my two solutions. If I were to do another 5/3, guys, you would be outside. So that's it. Like, you would be outside the domain. All right, let's keep going. Example 15 looks pretty much the same as example 14, between 0 and 7 pi. So let's go ahead and tackle this. It looks straightforward again. So I'm going to move the square root of 3 to the side. So I'm going to have 2 sine half x equals a negative square root of 3. Now, before I continue, I want you to recognize that I have a half x on the inside. So the period of this function is, let's see, it should have been 2 pi. And then that 1/2 stretches it by a factor of 2. So the period is 4 pi. So I want you guys to recognize that period is 4 pi. That's just something you should know from like basic pre-cal, right? So please make sure you guys recognize that before you become your medical doctors and your super awesome engineers over there. All right, so now I'm going to divide both sides by 2. So I'm going to have sine of half x equals a negative square root of 3 over 2. And before I continue, I'm going to stop right here. I think it is a good stopping point. And I'm going to say, okay, where on the unit circle is sine negative square root of 3 over 2? So on the unit circle, sine is negative square root of 3 over 2 in these two locations. So what are those locations? So here we go. Location 1, I'm going to write arc sine. I'm going to write 1/2 x equals, so the arc sine or negative square root of 3 over 2 happens in quadrant 3. and that's going to be, let's see, 4 pi over 3. And equation 2, and it looks like that x is at the bottom, right? It's not. It's half of x. Equation 2, 1/2 x equals, the other one happens at 5 pi over 3. That took longer than necessary. All right, and if I were you, I would write the plus 2 pi n, because then that puts you back in that same location. So plus 2 pi n plus 2 pi n. And again, that x looks like it's on the bottom there, but it's not. It's half of x. All right, so what I'm going to do now, I'm going to multiply everything by 2. So here's equation 1 being multiplied by 2. So x equals 4 times 2 is 8. So 8 pi over 3 plus 4 pi n. That 4 pi n should not surprise you guys. That's my period. All right, I'm going to call that x1. And I'm going to go to x2 now. That's from equation 2 times 2 times 2. So I'm going to say x2 is 10 pi over 3 plus 4 pi n. Notice that if I add 4 pi, well, it's between 0 and 7 pi. So 4 pi is definitely between 0 and 7. So that means I can do one more from here and one more from equation 2. So I'm going to have 4 answers total. So x equals, so here are my 4 answers. My first answer is 8 pi over 3, comma. My next answer is 10 pi over 3, comma. And now I'm going to add 4 pi to it, guys. So again, common denominator, I'm going to turn that 4 pi n into, let's see, 4 times 3. So 12 pi n over 3. 12 plus 8. 12 plus 8, what's that, 20? So 20 pi over 3. And I need one more. 12 plus 10. So I believe that's 22. 22 pi over 3. And there it is, guys. Those are my 4 answers that will work for this. All right, is that it? Oh, wow. I think we finished it, guys. Wow, I didn't know we were that fast today. All right, so that's it. We have some very simple activities, guys. Try them out. I hope you guys are happy. Stay happy, and let me know if you guys run into any issues. Math issues, of course. So stay safe out there, guys. Don't catch a corona. If you do, I guess try and get some medical attention. Please, continue living on this earth because we care about you. And give it a thumbs up and subscribe, because why not? Life is good. All right. Talk to you guys later. Bye-bye.